So, oogenesis. Let's start. Let's go through oogenesis. Process of formation of mature female gamete is said to be oogenesis. Process of formation of mature female gamete is called as oogenesis. So, as we are seeing spermatogenesis, in the same way, that process of formation of sperms we call spermatogenesis. Now, oogenesis, which is markedly different from spermatogenesis. We'll see in the end what is the difference between the spermatogenesis and oogenesis. Oogenesis initiated during embryonic development. Very, very, very important. Oogenesis, because spermatogenesis initiated only after puberty, but oogenesis initiated during embryonic development when baby is in mother uterus only. When baby is in mother uterus, that oogenesis is generated, that started actually. So at the time, what happened during the embryonic development stage? During embryonic development, when the baby is in mother uterus, the story starts with when a couple of million gamete mother cells. So, couple of million gamete mother cells are getting formed over in the baby ovary when she is in the mother uterus. Couple of million gamete mother cells, we call them as oogonia, are formed within each fetal ovary. Remember that a pair of ovaries are present, each ovary couple of million gametes. Okay. No more oogonia. Very, very, very important statement here to be noticed over. No more oogonia formed after birth. No more oogonia. Whatever the questions we got here in the NEET in previously, every time they focused on the new concept from this particular small 3 paragraphs itself. Okay, so it is conceptual explanation, conceptual understanding required. So, along with the text lines, I am going to explain the dimensions of these. No more oogonia formed after birth. So, at time of birth, how many are formed? Before birth itself, couple of million gamete. When it is formed during embryonic development, when the baby is in mother uterus. These cells start division, enter into the prophase 1. Do they started division already? Yeah, they started division. At what stage they are present? Meiosis 1 and prophase 1. They are in meiosis 1 and prophase 1 of meiotic division. Get temporarily arrested in that stage. How much time? That we'll discuss after this. Temporarily, at least up to the puberty, temporarily arrested at that stage. That stage, what it means? This stage, prophase 1. So what do you call them as? Primary oocyte. Primary oocyte. Okay, oogonia turns into primary oocyte. Okay, so each primary oocyte, a primary oocyte who is at meiosis 1 and prophase 1, a primary oocyte which is at meiosis 1 and prophase 1, surrounded by a granulosa of cells, the cells of granulosa. These are the cells of granulosa. What do you term it as? Primary follicle. What is primary follicle? A primary oocyte. This is primary oocyte, which is at meiosis 1 and prophase 1, surrounded by granulosa cells, is called as primary follicle. Primary follicle. Okay. Large number of these follicles degenerate during this phase from birth to puberty. From birth to puberty, large number will degenerate. How many will remain? 60,000 to 80,000 at the age of puberty. So, from where that number started? Couple of million oogonia are present when they turn into primary follicle. From the birth to the puberty, from the couple of million, they reach to 60,000 to 80,000. Okay. So then primary follicle gets surrounded by more layer of granulosa cell and a new theca. Now I'll show that diagram also here. a theca. This is the theca. Okay, I use another color for granulosa cells. These are the more granulosa cells. More granulosa cells. As usual, primary oocyte. As usual, primary oocyte. Okay, so theca, these are the granulosa cells, more granulosa cells, and that primary oocyte in the center, which is at meiosis 1 and prophase 1. So, what is it called? Secondary follicle. So, in this page itself, we learned about the primary follicle. What are the properties of the primary follicle? There is a primary oocyte in the center that is temporarily arrested at the stage meiosis 1 and prophase 1. No more oogony after birth. Okay, let's talk about primary oocyte. It is primary follicle having a primary oocyte which is at meiosis 1, prophase 1 and a layer of granulosa cell, a layer of granulosa, single layer. Okay. So, at these kind of 60,000 to 80,000 primary follicle only left in each ovary, most of them are degenerated. Then primary follicle, after that it turns into secondary follicle. Sir, how to recognize it is a secondary follicle? Number one, theca. Number two, more granulosa cells, layer by layer, getting formed. That is identification point of secondary follicles. Okay, identification point of secondary follicle. Okay, so remember it as identification point for each cell. That is very important for us. Okay, moving on. So I have to erase this. Wait a minute. So that is the previous part we are seeing. Now moving on to the second one, and then after let's talk about tertiary follicle, Graafian follicle. So to avoid the confusion from the previous page, I just am erasing, but I'll show necessary things here now, necessary things for you. So I erased the total. Wait a minute, wait a minute. So primary follicle, secondary follicle. They addressed primary follicle and secondary follicle in the previous page. Now, let's talk about it. Now, let me write here, sir, what is primary follicle? A primary follicle which contain granulosa cells. A primary follicle is a cell, a follicle which contain granulosa cells and a primary oocyte. Who is it? Meiosis 1 and prophase 1 who get arrested at that stage. So, what do you call this as? Primary follicle. So, how do you recognize the secondary follicle then? Secondary follicle. So, we said secondary follicle, which means a theca, a layer called theca, and more number of granulosa cells, the layer by more layers of granulosa cell, and as usual, primary oocyte in the center. That is secondary follicle. Okay, number one, primary follicle. Number two, secondary follicle. This is the story we are seeing in the previous page. Now, secondary follicle soon transforms into tertiary follicle. Sir, how to recognize tertiary follicle? So, how we recognize the secondary follicle? There is a theca. There is more granulosa cell, more granulosa cell. As usual, primary oocyte in the center. As usual, primary oocyte in the center. So, now let's talk about tertiary follicle. Secondary follicle soon transform into tertiary follicle, which is characterized by fluid filled cavity called antrum. Let me draw. How do we recognize? This is the theca. As usual, we have to continue with the theca and granulosa cells. Need to talk about the granulosa cells as usual. I just increased the size, that's all, which facilitates me to show you a gap, a space, which what do you call antrum cavity. This is the Primary oocyte as usual. Primary oocyte as usual is there. Now what he said? Anthem, a fluid-filled cavity, anthem. Anthem is a characterization of tertiary follicle. Okay, then theca layer is organized into outer theca layer. Now I am transforming. The theca layer organized into inner theca interna, outer theca externa. Inner theca interna, outer theca externa. Okay, so listen carefully. Once, if you focus here, there is no need to read back again. So that's why listen carefully. So first, in the characterization, let's talk about small technical issue. Hmm. So I am just showing what they are saying. I am just showing what they are saying. So this is the theca layer, the black one. Okay. Now theca layer organized into theca externa, which is outside, and same black I am using to show the theca interna. So theca externa. Okay. Theca interna. This is even tertiary follicle. Tertiary follicle now transforming theca externa and theca interna. It is important to draw your attention that it is the stage that the primary oocyte and within the tertiary follicle grows in size and complete its first meiotic division. Okay, so that what he is saying, in the primary oocyte which is present in the tertiary follicle undergo meiosis 2, meiosis 1, and it form two cells. One secondary oocyte and a first polar body is also formed at this stage only. At this stage only. Okay. So follicle grows in size and completes its first meiotic division. It is an unequal division. First meiotic division. So questions ఏంటి ఇక్కడ? First meiosis 1 completed at what stage? Tertiary follicle. Within the tertiary follicle. It is important to draw your attention that primary oocyte within the tertiary follicle. Within the tertiary follicle. That's why I am showing in this diagram. When does that meiosis 1 is completed? Okay, when does it completed? When a tertiary follicle stage comes, it is completed. So what is in the tertiary follicle then? Sir, tertiary follicle contain first primary oocyte, then second secondary oocyte. Okay, that contain both. What is primary follicle contain? Primary oocyte only. Secondary follicle contain primary oocyte only. But in the tertiary follicle, a primary oocyte turning to the secondary oocyte. So that's why definitely we can say both are present. Okay. So unequal division it is, yeah, that polar body is smaller in size, unequal division resulting in the formation of large haploid secondary oocyte and a small, this is tiny first polar body. Okay, tiny first polar body is formed. Then continuation. Tiny polar body formed. Secondary oocyte retain bulk of the nutrient-rich cytoplasm. And whatever the bulk of the nutrient cytoplasm is present, that secondary oocyte is retaining, not for the polar body. So whatever this primary oocyte containing bulk of rich cytoplasm, nutrient, yolk substance don't come to the polar body. It will come only to the secondary oocyte. That is the one information they said. Can you think of any advantage? Yeah, there is an advantage. After fertilization, that zygote division requires some nourishment, that they are making their arrangements for that. Does the first polar body born out of the first meiotic division divide further or degenerate? No, it doesn't matter for us actually. Whether it divide or degenerate, it doesn't matter for us because we are going through this particular secondary site only. At present, we are not very certain about this. They only answered tertiary follicle further changes into mature follicle or Graafian follicle. Now we should talk about this one, tertiary follicle further transformed into mature or Graafian follicle. At least I have to complete this particular, the other form of tertiary follicle. Let me complete that process. As I said to you, tertiary follicle transforming into tertiary follicle changes. First, theca is transformed into theca externa, theca interna. Granulosa cells, as usual, we have to draw. Now I have to draw secondary oocyte, isn't it? Because in tertiary follicle, meiosis 1 is completed, meiosis 2 results what? Secondary oocyte. Okay, secondary oocyte. Then anthem as usual. So, for primary follicle, we drawn a diagram. For secondary follicle, we drawn a diagram. But tertiary follicle require two diagrams. If you don't draw two diagrams, that you will be confused. So, what are the changes in tertiary follicle? Theca turns into theca externa, theca interna. Granulosa cells as usual. Anthem cavities develop. Primary oocyte turns into secondary oocyte. They undergo meiosis one, a tiny polar body, and a secondary oocyte is formed. So, now the tertiary follicle is having what? Secondary oocyte. Previously, what is in tertiary follicle? Primary oocyte. Now it is turned into secondary oocyte. Previously, tertiary follicle is having single layer of theca. Now it turns into theca externa, theca interna. So, presence of anthem, theca turns into theca externa and theca interna. Primary oocyte turns into secondary oocyte, are the characteristics of. You should stop at tertiary follicle. You have to revise like this in tertiary follicle. Okay. Now, secondary oocyte forms a new membrane called, at present, what we are talking about? Graafian follicle. This is the climax. The last follicle said to be Graafian follicle. Need to make arrangements here. Whatever comes new, that I will draw with another color. Secondary oocyte form a new membrane called zona pellucida. I am just drawing zona pellucida. Surrounding it, form a new membrane called zona pellucida, which is surrounding the secondary oocyte. Graafian follicle now ruptures. Okay, so some issues are missed here in the text. So, but let me draw for you the remaining. That as usual, I have to draw theca externa outer layer and theca interna inner layer, and that what do you call granulosa cells. Now you have to say membrana granulosa, theca externa, theca interna, and anthem cavity as usual. Secondary oocyte now, secondary oocyte. Okay. So, what is the additional layer mentioned here? Only according to the text I have to go means zona pellucida. So, what can be asked here if they want to ask along with the text? What is the additional in Graafian follicle? Zona pellucida, sir. There are so many other, but text angle when you talk about zona pellucida, sir. Only zona pellucida. So, that you have to remember. So, whatever the diagrams are required for this, I just shown here that primary follicle contain primary oocyte, granulosa cells. Secondary follicle, primary oocyte as usual, and additional layer is theca. Additional layer you have to remember theca. I am just putting star mark, can be asked as a question. Theca is formed in secondary follicle. More granulosa cells is the additional characteristic of secondary follicle. Next, tertiary follicle. What are the characteristics? Theca turns into theca externa, theca interna. Primary oocyte turns into secondary oocyte. Presence of anthem are the characteristics of tertiary follicle. Sir, how to recognize Graafian? Zona pellucida is formed. Zona pellucida. So, first of all, let me complete the story of text here. Graafian follicle now ruptures, release secondary oocyte, form the ovary by the process called ovulation. That means the theca externa, theca interna, granulosa cells will remain, and inner layer, what do you call the inner one? Secondary oocyte. surrounded by zona pellucida, a glycoprotein layer, zona pellucida. We have one more that is not mentioned in the text here, that is corona radiata. In diagram it is mentioned, corona radiata. I have to draw that also here, corona radiata. Just I went through the text, that's why I just, theory sentences we just went through. That's why we made like this. Okay, so now let's go this, the same for explanation. So till here we are seeing. So these are the diagrams. These are the diagrams. Let me erase this. Total primary follicle, secondary follicle, tertiary follicle, Graafian follicle. I think you don't have any problem here, sir. How to recognize primary follicle? Primary oocyte is there. Primary oocyte is there. And then next, what next? Some one layer of granulosa cells. Okay, so what next? Secondary follicle. Sir, how to recognize secondary follicle? More layers of granulosa are getting formed over and more layers of granulosa and both having primary oocyte. You should remember it as. More changes are there in tertiary follicle that you have to. Theca turns into theca externa and theca interna. Okay, that is the one change. Primary follicle turns into secondary follicle. Sorry, primary oocyte turns into secondary oocyte. Theca into theca externa and interna. Sir, what is the change in Graafian follicle? Graafian follicle, additional, they said, zona pellucida. Okay. So, now with the diagram, we have to add some issues here with the diagram. See, sir, where it is primary follicle? Where do you see the primary follicle? Some more applications are there. For that, I am going to the board in this area. Some more applications are there. I want to share board to you. It's the board. Yeah. Now, so whatever we learn now, till the time, whatever we learn, just we'll put on the board here. We'll put on the whiteboard. So now I am writing on the board. So each and every property we have to analyze here. Each and every property. Let us analyze. So first of all, primary follicle. First of all, we should talk about primary follicle. Okay. So let's talk about primary follicle. All that issues related to the primary follicle we should talk about. Sir, how to recognize primary follicle? As I said to you now, primary follicle is having a granulosa cell and a primary oocyte. Granulosa cell and primary oocyte. So, what is the condition of primary oocyte at this stage? What is the condition of primary oocyte at this stage? Meiosis 1, okay, meiosis 1 and prophase 1. Where do you see this? In ovary. Where do you see this? In ovary. Okay. Then, till what time you can see this? This is very important. Till what time? So, this is all happened at the time of birth. In the ovary, we'll find primary follicles only. Till the age of puberty, as I said to you, till the age of puberty, out of couple of million, only how many will remain? 60,000 to 80,000 primary follicles are remain. Okay. Imagine there is a menarche at age 10. That means starting of the follicle growth. That means what do you call menstrual cycle? Menarche at the age of 10. Menopause at the age of 50. Menarche at the age of 10. Menopause at the age of 50. The total duration 40 years. a female for every 28 days, she require one of the primary follicle to mature Graafian follicle for ovulation process. One is required, 28 days to one. That means imagine for 1 year, a maximum I am writing here, 1 year, 13 required, 13 follicles required. So menarche, puberty age beginning, 10 years, menopause, end of menstrual cycle at the maximum 50. So in these 40 years, 13, every year 13, in that way if you calculate, a maximum number of follicle to be used over in the female, and if she don't have children, if she don't have lactational amenorrhea after the birth, all these things. That means here pure follicular usage we are talking about. 40 into 30, 40 years into 30. 28 days, 1 year, 13. Total duration of ovulation period, 40 years. So how many follicles she required? A maximum of 520. So our couple of million we said in each ovary first. Then after they degenerated into 60,000 to 80,000 in each ovary. Then how many she require finally? 520. Okay, only 520. How many primary follicle will come into maturation into Graafian follicle? In the maximum 520 only. That you have to notice. Okay. So, what about primary follicle? At what time this stage will remain like this only? That depends, because one out of these 60,000 to 80,000 follicles, first of all, I said only 520 maximum follicles only can become Graafian follicle in the whole life. So, one of the primary follicle after the age of 10, one of the primary follicle turns into Graafian follicle at the age of 10. Okay. So, some follicles in the ovary will wait at the age of 50 also to become a Graafian follicle. That you have to notice over, because for every 28 days, one of the primary follicle out of 60,000, one only selected to become a mature Graafian follicle. Okay. So remaining for next 28 days, next 28 days. So the 520th one at the age of 50, a primary follicle is turning into the Graafian follicle, which means this Graafian follicle, which is turning from primary follicle change, it is seized as a meiosis 1 and prophase 1 at 50 years back. We have to understand that particular phenomena. That is why the quality is going to be changed in these cases. Quality of this is going to be changed. Okay. So this is the story of primary follicle. Every 28 days, one of the primary follicle turns into secondary follicle. Then secondary follicle into tertiary follicle. Tertiary follicle into Graafian follicle. Tertiary follicle into Graafian follicle. So, for that, out of 60,000 to 80,000, only one primary follicle only turns into the Graafian follicle for every 28 days. So, this is the story. This is the story of oogenesis. This is the story of oogenesis. Okay. So,